Patterns physics students. Hey, Mr. Trimble here. Today we're going to do our first supplemental lesson in preparation for our distance learning as we're all out of school for a while. Today I want you to pull out two things. One, you're going to need your iPad. You're probably watching me on your iPad right now. If you want, you could watch this video also on your phone, and then you could use your iPad on the side. Personally, I also use my laptop, and I'm always back and forth. If you have your science notebook at home, I want you to keep using that. In fact, we're going to keep taking notes in the notebook, and I'll have you take pictures of stuff you do with your iPad, and you will be sending in those pictures through Google Classroom. What if you left your notebook in the classroom? It's in your locker at school. You don't have it. You can ask the school to go look for things, and they will bring it to you at the door, or you don't have to do that. Just get any piece of paper. All right. I don't actually care if you use a notebook. I do want you to hang on to all your work because we are going to move on and have some summative work as we move along. This is a piece of printer paper. You might also have some notebook paper at home. If you don't have pencils or paper, the school is giving out free pencils, pens, paper, crayons, and pencil sharpeners every morning from 9 a.m. to 11 a.m. And that's going to start on April 6th, and I believe it will go into the future. So if your pencils run out, if you don't have paper, there is always a chance to get more for free. The school has you covered. So let's get started. I want you to pull out a piece of paper. We're going to take some notes today, and then we're going to make some graphs, and then you're going to write a quick summary. This won't take long, and it should be very similar to what we do in class. All right, grab your pencil, grab your paper, and let's get started. All right, guys, so the first thing I want you to do is I want you to look at the top of the page, and I want you to write yourself a title. These notes today are going to be called Graphing Patterns. Graphing Patterns. Those of you who still have your science notebook at home, we're on page 67 in that notebook. If you guys don't have your notebook, just grab a piece of paper. If you're starting a brand new notebook today because you're at your house, that's fine. Just start on page 1, call it page 67. It really doesn't bother me as long as you are doing this work. When we're done with this today, you are going to take a photograph and submit that to Google Classroom. And that's the way I'll be able to see what it is that you're doing. I'll be able to read your summary. Let's start every single lesson the same way with an essential question. Let's all write the essential question. The reason is that if you get lost, if you get bored, if you get stuck, you go back and you read that essential question and it tells you exactly what we're going to do. All right, here we go. How can I use graphs? To identify patterns in nature. All right, we're going to start with a graph of some example data, and then I'm going to give you a graph of some very real data that's being collected right now around the world, and we're going to graph that and see what kind of patterns we can see. I'm going to draw myself a nice horizontal line. You don't have to do that. I just don't have lines on my paper, so I like to do it. Let's start with a quick review where we are going to take a look at 4 different patterns that we always look for in this class. So draw yourself 4 Cartesian planes. Here we go. There's a little L shape. Here's a little L shape. And you guys know my handwriting can be pretty rough, but what are you going to do? All right, there's 4 little L shapes. Your horizontal axis is always called the x-axis. The vertical axis is called the y. So I'm going to write x, y, x, y, x, y. All right, and please write that each time. I know it seems redundant, but it's good. Part of this is we're getting this stuff burned into your brain so that one day you will never have to think about it. It'll just be there. All right, the first one that we're going to look at, this is the first graph we had in class. I'm going to draw a dashed line like this. I'm going to bet you already know the name of this. So I'm going to draw all 4. The second one looks like this. The third one is going to look like this. Nice curve going upwards. And then the last one should look like this. It's going to curve downwards. Now make sure when you draw this that that particular curve never touches the X or the Y axis. That last one, it's very important. All right, right now before I say it, pause the video and label all 4 of these from memory. Okay, I'm hoping now you've done that and you've unpaused. If not, it's cool. The first one is called a horizontal line. Horizontal. The second pattern there is what we call linear. L-I-N-E-A-R. Line with A-R on the end. The third one is called quadratic. Q-U-A-D-R-A-T-I-C. Quadratic. And our last one is called inverse. I-N-V-E-R-S-E. All right, horizontal, linear, quadratic, and inverse. Now we have our 4 patterns. You know, in the class we have the posters on the wall. You guys have these in your notebooks. Now you've got them again. If you're hanging on to these notes, I want you to keep all of them. You can refer back to this every time you get stuck or lost. Let's draw a horizontal line. We are going to do example number 1. Now we're only going to do 2 graphs today, guys, so don't get too worried. Example 1. All right, I'm going to scroll down. All right, we're going to start with a little data table. All right, we're going to have X and Y. Draw a horizontal line and nice little T chart. All right, I'm going to start with some X values. We have 0, 5, 10, 15, 20, and 25. All right, I'm just picking some numbers here, and you'll see that it makes sense here in a sec. Our Y values, I'm going to give you these. Let's say you did some experiment, and your results showed you that your Y value was 0. For 5, you had 25. For 10, you had 100. For 15, you had 225. For 20, you got 400. And for 25, the Y value was 625. And if you guys remember, we always talk about independent variables and dependent variables. Right now, just think of this like your algebra class. This is just a set of numbers, and we're going to graph them. So over on the right side, if you have graph paper, maybe you're writing on graph paper, that's awesome. Maybe you want to cut out some graph paper and glue it on your page. It really doesn't bother me. Maybe you want to do it separately. I'm just going to draw it right here. Since this is a review lesson, it's not the end of the world if it doesn't look perfect. All right. I'm going to draw an X and a Y, X, Y. So my X values need to go from 0 to 25. All right, they don't start at the number 5. It always wants to start at 0, and you always want to go to the number 25. So since I don't have graph paper, I'm just going to eyeball this thing. All right, I'm going to say if that's 25 and this is 0, I feel like I could go 5, 10, 15, 20, 25. And I'm going to try and draw some lines that I think are about the same. If we were doing a lab, I'd ask you to use graph paper or a computer or a ruler. Now let's go vertically. I'm going to start at 0. That's my smallest y-axis number. And my biggest number on here is 625. Now 625 is kind of a strange number. It doesn't quite fit. So I think I'm going to go from 0 to 700. That's going to enable me to graph every y value from 0 to 625. And you know what? Why don't I just draw them by 100s? Why don't I say something like 0, and then we'll do like 100, 200, 300, 400, 500. That was an ugly 0. 500, 600, 700. And do you guys see how I'm just doing this the best I can? We're just getting our brains moving again. So now I have a nice little plane. I have X and Y axes. Now I'm just going to graph these points. I have 1, 2, 3, I have 6 different points here. I'll choose brown as my number. All right, I want you to graph these with me. So right now what I'd love is if you pause the video and then you graph all 6 of these points, and then we'll come back in just a sec and I'll show you what I'm gonna do. So hit pause and then come back in a minute. Okay, I'm gonna assume you're back now. Here we go. 0 graphs with 0. So I'm gonna put a dot right there. In fact, I'm gonna make it nice and big. It's brown for me. I'm gonna go over to 5. This is my second set of numbers. I'm gonna go over the number 5, and then I'm gonna go up 25 units. So I'll go over to 5. Ooh, but there isn't a number 25. What do? I'm gonna go to 100, and I'm gonna say, what's about 1/4 of the way up to 100? It's probably about right there. My next one is 10 and 100. So I can like go up, and I can say, here's 100. And so my dot is gonna be like right there, maybe? I think that looks good. I'm gonna get rid of all my ugly little lines there that got me there. Go away, go away. 10, 100. I see 15 goes with 225. So that dot's gonna be up here. Ooh, that's starting to curve. 20 is gonna go with 400. Something like right in there. And if you have graph paper, your graph looks so much better than mine. And 25 is going to go with 625. Something like that guy up there. All right, the next thing we want to do is we want to draw a line of best fit. Now, I'll be honest. If it was me, I'd be like, let's draw a line through that. But, oh, doesn't want to do it. Let's try it again. I'd say, I want to draw a line. And I try to put a line up here. That doesn't fit. I can fit a line down here. Oh man, there's no way to fit one line through all these points. We're gonna have to make it a curve. So this is a little trick I do. I always like to turn my paper upside down, and then I draw my line this way because I'm right-handed. If you're left-handed, it's actually easier to do this. If you're just good at drawing curves, go for it. I'm gonna draw my curve starting at 0. Try to draw one smooth line. I like to draw an arrow at the end just to say, data goes on forever. Now, if you look back at your stuff at the top, you should be able to tell there's one pattern that this fits very, very well, and that is a quadratic pattern. Q-U-A-D-R-A-T-I-C. Quadratic pattern. And generally, a quadratic pattern is something like y equals x squared. Now, it's not always squared. All right, it's not always that it's y equals x squared. Sometimes it'll be y equals 3x squared or 1/2 x squared. There's lots of different ways to do it. And then there's also ways to graph it where it could be x to the 3rd power or x to the 4th. Models get really, really crazy. But for right now, let's just say quadratic is x squared. And in fact, this particular graph that I've just made is y equals x squared. You could plug those numbers into Desmos, get yourself a fit, and it would work really, really well. All right, now let's go out and look at nature. I'm gonna draw a horizontal line. We're gonna make one more graph, guys. Please stick with me. I'm gonna call this example 2. All right, example 2 is gonna be some data from nature. Now, I'm not talking about the woods or some forest off in some distant place. I'm gonna talk about the entire United States of America. And there's this one species in America called human beings. And recently, in the last 28 days, we have a brand new disease. It's running through the population. It's called COVID-19. That's called coronavirus disease 19. All right, what I want you to do right now, I want you to either, right below this video, there should be a link to a website that has some graphs in it. You can also go back to Google Classroom, and I've got it linked there right next to this assignment. I'm also going to pull it up right here on my iPad. So what I'd love for you to do is click on that link, look around at some of the graphs, and then I'm going to pull them up right here as well. All right, if you click on that link, it takes you to this website, which is a interactive visualization of the exponential spread of COVID-19. All right, there's some stuff to read here, but I'm going to scroll down. When you first go to this website, it's going to look like this. All right, you are going to see on the left side, it says confirmed cases. That's the number of people who have this new coronavirus disease. At the bottom is days since 100 cases. That's the x-axis. So this is a bunch of countries, and it's showing how many people have this new disease. And it starts with 0 being that's the day when there were 100 people in the country who had it. Because that's kind of the day where we can say, here's where the disease really takes off. If it's only one person, it hasn't really started yet. Now you're going to notice, take a look at the y-axis on this graph. You're going to notice that on the left side, this is actually pretty interesting, on the left side it goes 100, 500, 1,000, 5,000, 10,000. Those numbers are not in order. In fact, if you were to make a graph like this in my class, I would make you redo it. This is what we call a log scale. It's not something that we do in this patterns physics class. It's going to be something you'll learn in something like an Algebra 2 class. So in the bottom right corner, I'm going to click linear scale. So go from log scale to linear scale. And now, if this website's still working the way it was, the way I sent it to you, you're going to see United States. And in fact, if you're watching this video a few days after I made it, that little orange line is going to keep changing. So it'll be interesting to see what it looks like. Now we have a y-axis and an x-axis, and they're both linear. So the horizontal axis goes from 0 to 45, nice, clear steps. The vertical y-axis goes from 0 to 500,000. Goodness, it's really big. Hey, let's see if we can't break that down, all right? Make a quick little graph and see if we can't describe that pattern. So right now, why don't you take your iPad, hit both the button on the side and this button here. Boom, take yourself a screenshot because that's a really cool graph, and let's hang on to it. And then as soon as you do that, let's go right back to Notability and let's make ourselves a t-table. All right, here's a horizontal line, here's a vertical line. The first one is going to be days. The second one is going to be people. So days is going to be our x-axis, and people is going to be our y-axis. All right. Now this starts with 0 days. This is actually where I'm making this. This is 28 days ago. 0 is the day when there were 100 people who had coronavirus in the United States. And we're going to go by 5s because I don't want to graph every day. That takes too long. All right, so I'll go 0, 5, 10, 15, 20, 25, and 28. Why do I stop at 28? Right now, it is April 3rd where I am. April 2nd was the last day that this data was updated. That was yesterday. And that was 28 days since the infection really took off here in the United States. So on the y-axis, let's write the number of people. These are the number of people in the United States who have confirmed cases of COVID-19. And I'm just going to write these numbers down because these are the real numbers. 100. On day 5, there were 500 people with this disease. On day 10, there were 2,600 cases. On day 15, there were 13,633 people in the United States. On day 20, that went up to 50. Ooh, no, I wrote that wrong. On day 20, there's 53,691 people. On day 25, that's 140,000 people, 837. And then on day 28, that was April 2nd, that's 243,404. Now, if you're at home, and let's say it's the middle of next week, it's April 7th, April 8th, whatever day it is for you, this orange line that you see, it's going to keep going up. Maybe it's going to start changing. I don't really know. I can't see into the future. So if you want, you can hover your mouse or you can click on each of those dots and it will tell you how many data points there are at any given spot. Actually, yeah, there it is. So United States, day 28 was 213,323. You can click on any of those points and it will tell you the data on that day. This is all I've done. I've just pulled these numbers. So let's make ourselves a quick graph. Once we make this graph, we will be done. I know you guys want to move on with your lives. Let's draw a y-axis. Let's draw an x-axis. All right, the x-axis is days, D-A-Y-S. And we'll go from 0, let's go up to 30, just because 28 is an ugly number. And I'll go, how about like 5, here, I'm going to zoom in on this a little bit. 5, 10, 15, 20, 25, 30. If you have graph paper, man, your graph looks good right now. If you don't, it's cool. Do your best. On the y-axis, I'm going to go from 0. Ooh. Okay, as of right now, as I'm graphing this, the maximum number was 243,000. Now, we know that number is going to get a whole lot bigger. So if you want, you can look at the real data that you're seeing today, and you can graph whatever that is. Maybe it's 300,000. In a perfect world, it would just stop. Maybe it's 1 million. I have no idea. I can't see the future. But here, I'm going to graph it up to 250,000. And if you want to just stick with me, you just graph what I got. It's all good. So now I'm going to look at this and think, how do I want to do this? 0 to 250,000. I can think of 0 to 25. In fact, I got 5, 10, 15, 20, 25. If I just add 1,000 on the end, that makes this pretty easy. So let's go 0. Let's go 50,000. And then let's do 100,000. Let's do 150,000. And how about 200,000? And you know, Mr. Trimble would get in trouble if he drew this without a nice scale on the horizontal. Let's make sure that we name this people. People with COVID, all right? And if you stay home, you're not going to get this, all right? If you stay home, you're going to stay safe. You're going to keep your parents safe. Let's graph some numbers. On day 0 on this graph, there were 100 people who had COVID-19. Oh golly, look at this. There's 0. There's 500,000. Y'all, 100 is like way down here. So in fact, it's so low on this graph, I'm just going to make the dot pretty close to 0. On day 2, well, day 2 doesn't matter. On day 5, there were 500 people. So let's look at this again. I can't even, 500 out of 50,000? I mean, that's tiny. I'm going to put this dot just like barely above the line. So my video cut out, so I'm recording a narration now of the rest of this. So we now have 0 to 250,000 people on here. All right, and so what we're going to want to do is try to graph these points. So if we look at the bottom, you see 0, 5, and 10. All right, all of those are really, really small on the graph. So they're basically going to be touching the bottom. Now when we look at 15, that's going to be a little bit different because 15 is 13,633. That's maybe like a third of the way up to 50,000. So I'll just make a nice big dot, kind of fit it in there about a third of the way up. At day 20, we're looking at almost 54,000 people. Let's just round that to 50,000 for now. All right, just put a dot right above 20 and just off to the side of 50,000. It's good enough for this graph right now. And now the last one, we're going to be at day 25 and 140,837 people. Why don't we put that up there just right below 150,000? Just a nice little green dot up there. Should show up in just a sec. There it is. And then lastly at day 28, I don't have a 28 on here, so we'll just go right to the left of 30. We're at 243,000 people. And man, it's really increasing now. All right, so the next thing to do is to go in here and we're going to make ourselves a nice little curve to fit the data. I like to flip my iPad or my paper upside down, get it in there, start with 0, draw yourself a nice little curve. There it is, going up, 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 up. And I draw an arrow at the top because this disease is not over and you're watching this on day 30 or day 35. Hey, let's look at the pattern. Y'all, it looks a lot like the pattern we drew up above. We called that quadratic, x squared. This is not actually a quadratic graph, all right? It looks a lot like quadratic. In nature, these diseases tend to be something a little different called exponential. That's exponential. It looks like quadratic. If you called it quadratic, it wouldn't bother me. In fact, I'd be impressed. Exponential is a little different because instead of y equals x squared, it's y equals 2 to the x. A subtle little difference makes the curvature of the graph and the pattern go a little bit different. And you'll see we had y equals x squared, we had y equals 2 to the x. You will learn more about exponential patterns when you get into higher levels of mathematics, and the differences between quadratics and exponential can get really interesting as you move along. All right, so why does this matter? You're going to hear about COVID-19 every single day if you watch the news, and you're going to be learning a lot about the way this works. What you've just done is made a graph, and you fit it to a mathematical model. All right, now this is exactly what scientists do. You see that little red arrow I just drew? That is the point where it's like the curvature suddenly appears to increase dramatically. The reason we are not in school is to keep that curvature from increasing even more. Now, if you watch the news, you're going to see this guy. His name is Anthony Fauci. He's the director for the Center of Allergy and Diseases, and behind him is the President of the United States, who he is advising. Now, you're going to hear Fauci, if you listen to the news, he's going to talk a lot about the Center for Disease Control and our models. These models are computer models that predict the future of the disease. Y'all, this is the exact same thing we do in patterns physics. We look at data that we collect from the world, we fit a line to the data, and then we extrapolate that into the future. When you hear Anthony Fauci or anyone on the news talking about mathematical models, they might say the term flattening the curve or stay indoors so that we can stop the spread. All right, you see this red line I've drawn? That's what would happen if we all kept going to school. All right, since we stay home, we're going to be able, over time, to make the increase in the number of cases slow down. And eventually, we want that to turn into a horizontal line, which means no new people get this disease. Now, it's never going to totally stop, but our goal is to slow it down as slow as possible to try and make those curves really nice and flat so that the doctors can take care of the people who are sick. So the rest of us will stay home to help everybody else. Hey guys, let's wrap this up. I got one last thing for you. All right, I want you to scroll down. I want you to draw a horizontal line down there at the bottom, and I want you to write the word summary. We always finish our assignments with summaries or conclusions. Today it'll be a summary because this isn't over yet. What I want you to write is 2 to 5 sentences. All right, and I'm pretty sure I wrote this wrong, and then I erased it. Yeah, there it goes. All right, 2 to 5 sentences, and I want you to just summarize the essential question. All right, this doesn't have to be some big thing. I want you to write just a little bit about this essential question. All right, how can I use graphs to identify patterns in nature? Just look at what we just did. We pull the data from a reputable source. We put it into a data table with regular intervals. We make a graph with an X and Y axis. We label the X and Y axis and give them regular numbers. They go in a repeating pattern. Then I graph the numbers. I draw a line of best fit. I identify one of my 4 patterns: horizontal, linear, quadratic, inverse. And then, if you really wanted, you could plug this into a computer or into Desmos, and you could figure out a mathematical regression. I'm not going to make you do that. If you want to, you go for it. You go for it. If you're really into it, get on it. It's cool. And what we're doing in this class is the same thing that these scientists do out there in the real world. When you're done writing this, what I want you to do, scrolling down here, what I want you to do is to take your notes. All right, maybe it's 1 page, maybe it's 2. I want you to take a photograph of the notes with your iPad. All right, so here I am zooming out, take my iPad, I'm gonna take a photograph of those notes. I'm gonna go back to Google Classroom, to the app, attach that photo to the assignment and hit the button that says turn in. All right, don't email it to me. Don't share it with me. Go to Google Classroom, attach it to the assignment, and press turn in. Once you do that, it's going to send it to me. I'm going to take a look at your work. I'll give you a couple points in Google Classroom just to say that you did it. This does not affect your grade in Hack, but it is something that I want you all to do, because when you take this notes and you turn it in, you're telling me, hey, Mr. Trimble, my iPad works, my internet works, and I'm ready for school on April 13th. Because once school starts, all right, if you're not doing your work, you're going to get behind pretty quick. So this is a lesson for you to get started and to get ready and to be prepared for what we're going to do in the future. All right, guys, we're going to keep using our science notebooks. If you want to get a new one, that's totally fine. Remember, if you need paper, go to the school. They have free paper from 9 a.m. to 11 a.m. Paper, pencils, breakfast, lunch, pencil sharpeners. We got you hooked up, guys. Anything you need. Hey, stay home, stay safe, and whatever you do, please don't leave your house unless it's absolutely necessary. And if you do, wash your hands, change your clothes, take a shower. All right, guys, I look forward to talking to you again on April 13th with our first distance learning official lesson. We're going to learn about waves and technology. We're going to learn about light coming through the window and how it's very similar to the waves of sound coming out of your mouth. Have a good one, guys. I'll see you next week.
I am Groot.